I had a question too.
Okay.
How gives several specific examples of how negative feedback systems regulate the body, and then it says body temperature, body pressure, blood glucose, and then I don't know what we're supposed to do.
Okay. Let's talk about negative feedback loops. This is a
Chapter 4 is like intense too. I'm kind of nervous for that, so we'll have to go over that more on Thursday. And can I meet with you one more time too, like on Wednesday instead?
Yeah.
Can I do Wednesday and Thursday this week?
Yeah.
Do you have Wednesdays open at 9 again? Or when's your time?
Do I have? When do I have?
Because I want like an hour to go over like the pre-test, and then I want like
Because
time to
Wednesdays
go over
Wednesdays I don't have morning open.
Okay. Do you
Because
have afternoon? Or anything?
I may not have anything.
Okay.
Because I work the lab for this class Wednesday mornings.
Oh, okay.
And so I'm already like.
Maybe I'll do Friday then, and I'll just take the test Friday.
Yeah, you can do Friday.
Okay.
I believe I have some Friday morning.
Okay, I'll do Friday morning. I think Sky's gonna come too.
Yeah.
We want to talk about the test and then 4. But I'll do a little bit of 4 today.
Okay, so let's talk negative feedback loops.
Okay.
Okay, so there's 3 parts to a negative feedback loop. There is sensor, control center. Now the control center always puts out a hormone or some other signal. But just remember, hormone for most of this class is going to be a hormone. Mm-hmm. Okay. Now hormone talks to the effector. So the 3 main parts is this, this, and this. This is just kind of the bonus, like in between the last 2. That's how it communicates. And it goes around in a cycle like this. So I'm going to explain these 3. So you have the sensor. And sensor, all it does is it receives information. And it's there to collect data, basically, to collect what's going on. It sends that data, that information to the control center. The control center then interprets it, decides, okay, is this good or bad? Are we at the right level we need to be? Are we too high? Are we too low? What's going on? So the control center actually interprets it and decides, okay, well, I'm going to do something about this. If something's wrong, I'm going to do it. But once it decides what's wrong, it sends a hormone to tell the effector to do something. The effector actually changes it. The effector actually changes the whatever process you're in back to the normal level. The hormone is there to tell the effector, okay, you need to change this. And once it changes it back, the sensor keeps sensing, and it keeps going around and around. It keeps. So, if this line is homeostasis for something, our body works like this. It gets too high, senses it, decides to change, control it, bring it back down. It gets too low, senses it, brings, and so it just goes like this, trying to stay, because we're never going to perfectly be at that level. Okay. Now I'm going to give you examples like he was asking for. So let's do body temperature. Okay. So we have our homeostasis line. Now if we got too hot, so that's high, so we're going above. We got too hot. I don't know how specific he wants you to know, but it's the brain is the sensor. And the brain just senses that and goes, ooh, we're too hot. And then the control center, which is also the brain, for the most part in body temperature, says, okay, we're going to do something about this. We're going to change it. So it sends a signal that causes you to start sweating. And sweating's the effector, those sweat glands, to cool you off. So sweat glands are helping cool you off. Also, other things that happen is your blood vessels come up closer to the surface so they can release heat. Closer to the surface of your skin so they can release heat.
Not your veins though, right? So you don't really see your blood vessels coming closer,
It's
or is it
usually-
your veins?
It's usually your arteries. That's why when people work out, they start having things stick out.
Uh-huh.
But it's either. They come
Oh,
out,
okay.
they release heat, and lots more blood is going to your limbs, which releases more heat. So those three things bring it down, and it goes back. But then let's say you go walk outside today, or it's super cold, and all of a sudden your body's like, whoa, we're low again. Like temperature is low. Now we're gonna need to fix this. And so your brain senses that, the control center decides, okay, we're too low, we need to change this. Sends a signal, tell the body to start shivering, muscle contractions that cause warmth.
Oh.
Or to bring the blood away from the surface of the skin and keep it more in your torso. Stuff like that brings your body temperature back up. And you realize we do this all day long, Whether it's for blood sugar, where you just eat a meal, your blood sugar is really high, and so your body's like, okay, we need to bring this down. Or
Wow.
or you're on a fast Sunday and you haven't eaten very much, your blood sugar is really low.
And it's cold at church sometimes.
Yeah, it's the same thing. So all those processes are called negative feedback loops, where it's constantly sensing it, deciding what to do with it with the control center, and then sending a signal to the effector to change it back to a normal level. Now, the positive feedback loop is different. There's only one positive feedback loop in the body that you'll need to know about. Negative feedback loops, every single chapter we go over, there's going to be a negative feedback loop. So just be ready. We're going to test you on negative feedback loops a ton. And negative feedback loops, his favorite short answer questions.
Yeah.
I'm telling you right now, I've seen more short answer questions on negative feedback loops than anything else in this class. So,
okay. So we're going to need to know.
So whenever I bring up a negative feedback loop, immediately go, I need to know this. This is going to be on the test for sure. In fact, he may ask you as a short answer, name the 3 parts of a negative feedback loop for this test. Name the 3 parts of a negative feedback loop and tell me what they do. So what would your answer be?
Like about the sensor, control center, and then hormones.
The effector.
Effector.
The hormone is kind of like the in-between. The
okay.
The hormone's just there to tell
That's what is sent to
the
message.
effector.
Okay.
If you added that, that'd be perfect. That would not be wrong at all.
Okay.
Because the hormone is how the effector says, hey, you need to do this, to the control center sends
That's how you explain it, right?
Yeah.
Yeah.
So the control center says, hey, you need to do this to the effector, because the control center says, I need to change this. So it tells the effector, hey, change it. And so the effector's like, okay.
So it's like the hormone's like the messenger?
Yep, exactly. Hormone is the messenger.
Okay.
Okay.
Cool.
So there's only one positive feedback loop in the body that I know of, and the only one that you'll ever talk about in this class. The difference between negative feedback loop and positive feedback loop, let's say that's the original state. Again.
Yeah, that's
This
the one I
time.
totally, I wrote down the book answer,
Yeah.
but I was like, I had no idea. Like, when things are called variables, I'm like, please don't
Yeah.
call it a variable. Like, I don't know what that means.
Yep. So this is like,
What is a variable, I guess?
depends.
I
I'd
feel
have
like
to
it
see.
changes,
I'd
you
have
know?
to see the context of
Okay.
this. So this is the original state. You know how with negative feedback loops we're wanting to, you stay around it like the
Mhm.
body's trying. Positive feedback loops, you go, okay, I have a reaction. That reaction causes more reactions. And 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 here's the end result. That result is completely different than that. You're not returning back to your original state.
Mm.
Here, like with body temperature, blood sugar, we're trying to stay at the original state, right? We're just always doing changes to keep it right there at our original state. Positive feedback loop, no, you changing the state. So
Is that why they give the example of childbirth?
Exactly. That's the
Because
only
your child's growing. It's not like you're just like...
So I'll explain. So that's the only example I know of is childbirth, where...
So men don't
So
even
one-
have positive feedback loop.
No. So this is... so you have a contraction.
Mm-hmm.
That contraction actually causes a hormone, oxytocin, to be released more. That causes more contractions. And the more contractions causes more of that hormone to be released, which causes more contractions, which causes more of that hormone to be released, which causes more contractions. And it keeps going, and it gets quicker and faster and more often. And then the end state is you have a baby. you're not getting re-pregnant. Like, it's not returning you back to a pregnant state. That'd be weird, you know? It's getting you to a new state where the baby's out of you. So that is the only positive feedback loop I know of, and the only one that you'll talk about in this class.
That is so crazy.
But because
That makes sense.
but you see how it's changing your state? It's taking you
Yeah.
from a pregnant state to an unpregnant state. You know, you don't want a negative feedback loop for babies because it's like, well, I don't want to stay pregnant and get re-pregnant. So,
I was like, yeah, childbirth. Like, what does that mean? But that makes sense.
yeah. And
Wow.
and those contractions actually stimulate more and more and more and more contractions.
Wow, that's interesting.
Yeah.